Hello everyone. Today I'm going to show my term project of digital design lecture, which is uh, a password lock. Uh, by this project, my aim to create a password lock, for every door, every lock. Uh, I will show briefly my project now. Uh, my initial conditions of my project. Uh, Initial conditions of my project is this. This is the first programmed device, and it waits us to set password. For this switch, by this switch, we are changing the state of the project, state of the program. For example, for now, it's at the try mode, and when we make it one, it's at the set mode, and at this mode we set the password. For example, I will enter 1, 2, 3 and A, and now it shows us the password. And now we at the try mode. At this try mode, we enter some passwords, and it checks whether if true or not. And if it's true, it triggers this step motor, and by this motor the key returns around itself, and it opens the lock. We have three wrong password chance, and after this three wrong password, the alarm is triggered. I generate alarm by this buzzer, and I send some signal, and it generates sound. I will talk about it later. Let me show that how I check and how my project reflects to trial input. And I also want to talk about these LEDs. These LEDs displays how many chance we have, how many wrong chance we have. Firstly, I'm going to enter the correct input, correct password, like 1, 2, 3, and 4, and you see that the key returns it's around itself, and the last password we entered is displayed at the 7-segment display. If we enter a wrong password, like for any wrong password, you see the one of the LEDs turned off. After that, again another LED turned off, and it says no chance left, and this is last trail before the alarm. And if we enter another wrong password, you hear buzzer generates the sound, which is triggered by three wrong inputs, wrong passwords. In order to stop the alarm, we need to enter a correct password. Let me show that. And the alarm stopped, and key is returning again. In this project, in this block, it reminds the state of the lock. Initially, it's set to open, and after that, when the password entered, it locks, and when correct answer and enter it again, it opens, and it's displayed. It can be understood that the direction of the step motor, any password entered, it changes its rotation direction. For example, when we enter the password, it for now it returns left counterclockwise, and after it stops at one turn, after one turn, and now we enter the password again, and it returns at clockwise, and again one turn, and it stops. That was the overall of my project, and now I want to talk about my components working plan. I want to start with stepper motors. I use a driver for stepper motor, which can be seen at now, and for this by this driver I send 4 different signals to step motor, and at the specific frequency, and it detects it controls the speed of step motor, and also at every turn one of the signals in the vector become 1 and another is 0, and the buzzer generates sound. We send some specific signals to buzzer, and buzzer generates that sound of that frequency, and at last the keypad is one of the compatible part of this project, and I want to talk about its inside its schematic. I used 4 matrix keypad, and you can see the schematic of that keypad. In order to work with that keypad, we need to declare columns or row in and another 2 out. I set columns to out and rows to in. I send for a specific at the specific frequency, I send one of the columns one signal, and check whether any of row is have any signal, any high signal, and we understand that if the any button of the keypad is pushed, and which button is pushed, we take 8. We have 8 connection from the keypad, and we reach a vector which is 8-bit vector from the keypad, and we can know that which button is pressed by analyzing that vector, and after that we can change it to 7 segment display. That was my project for digital design, and that was the overall of my project. Thanks for watching.